Thank you. Yes, this will be recorded. Thank you for joining us today. This is our first 2024 Rocky Mountain Hub webinar. We're really excited about this one. Today, we will be hearing from Anthony Pack from Preopta on the City of Vancouver's Embodied Carbon Guidelines. So Vancouver was the first city in North America to include embodied carbon in their policy, and we're hoping that learning about their approach, hurdles, experience, etc., will help us all in the Colorado area feel maybe inspired or determined to push our own legislation in the right direction. But before we get started with Anthony, I will just give a brief CLF overview, a little bit of news, I'll hand it away, and then we'll do a pretty big chunk of Q&A at the end. So some exciting embodied carbon news in our area. The Office of the State Architect announced on January 1st, 2024, the max global warming potential thresholds. So the Buy Clean Colorado Act applies to state public projects where the project cost exceeds $500,000 and where an agency of government issues a design solicitation on or after January 1st. And so on the left, you can see just a brief snapshot of what the limits thresholds look like. And please use the links provided on this slide to learn more about that. Brief overview of who we are. So we have 4 great co-chairs. On the far left, Michaela DeRousseau with Building Transparency, Victoria Herrero Garcia with Mead and Hunt, myself, Dorian Krause with Pathways, and on the far right, Bailey Vigil with the Office of the State Architect. So what is Carbon Leadership Forum? For those of you, maybe this is your first webinar you're attending, or you're just learning about what CLF does. CLF is an industry academic collaboration at the University of Washington. And the goal of CLF is really to accelerate the transformation of the building sector to radically reduce the embodied carbon in building materials and construction. There's a lot of research, resource creation, cross-collaboration, empowering member-led initiatives to bring embodied carbon emissions of buildings down to 0. Beyond that, there are many what they call focus groups, in addition to the regional hubs, that you can join if you find a certain topic that suits your interest. There are 15 of them listed here, and definitely reach out to us if you have specific questions on any of them. And if you aren't already, please join the Carbon Leadership Forum and create a CLF account. Just follow the link at the top there. And once you're in the community section, you select the group and choose from whichever regional hub or focus group you'd like and go from there. And just to close out the intro, here are a bunch of ways you can reach us. And also at the bottom is our great YouTube channel that we host all of the recorded webinars like the one today. And with that, I will pass it to Anthony.
Wonderful. Thanks. Let's see. Okay. Hi, everyone. Thanks for joining and to spend some time to learn a bit about the City of Vancouver's Embodied Carbon Guidelines and also the policy framework. So I'll be giving you an overview of that. Probably most of you are familiar with this, but I just always like to start off with, what is embodied carbon? When we're talking about embodied carbon, we're referring to the emissions associated with construction materials. So all the materials that goes into a building or an infrastructure. So things like wood, concrete, glass, steel, the emissions associated with those materials across all the life cycle stages from cradle to grave, so to speak. So everything from raw material extraction, transportation, manufacturing, processing, construction, operation, all the way to end of life for each of those materials. In recent years, there's been a lot of interest in embodied carbon from a policy perspective. And so this is a map from the Carbon Leadership Forum that shows you where there are policies and programs addressing embodied carbon, both in North America and also in Europe. So you can kind of see the red dots are the city or municipal level policies, city, county. The blue is national. The green is state and provincial scale. So there's lots of different policies. Just to cover a few of the more prominent examples, the City of Vancouver, which I'll be talking about, we're the first city to put it into the building code. And so I'll obviously be speaking more about that soon. But also in Canada, the City of Toronto, with their Toronto Green Standard, they have some embodied carbon requirements specifically for municipal buildings. And at a later point, it may apply to more private construction as well, but they've set some upfront embodied carbon limits on that. At the federal level in Canada, we have the Green and Government strategy from the Treasury Board Secretariat. So this applies to all the federal major new construction projects in Canada. And so they've currently they have a requirement for a 10% reduction on specifically the concrete for federal projects. And in 2025, they're looking to ramp that up to a 30% reduction in embodied carbon for structural materials, as well as requiring a whole building life cycle assessment disclosure. At the federal level as well, or not just federal level, at the national level in Canada, there's discussions about putting embodied carbon technical requirements into the national model code in the 2030 code cycle. So in 2030, there's an intention to put embodied carbon into the national code. So that's a fairly significant, obviously, how do I say it, requirement. But I think right now it's just we're still in the early stages of discussing what those look like. Over in the US, you've probably heard of Cal Green in California. They have embodied carbon requirements. So starting in 2024, June of this year, there's a 10% reduction for whole building LCA. That's one of three potential compliance pathways. The Pacific Coast Collaborative is a collection of basically British Columbia, as well as the Western US states, so like Washington, Oregon, California, as well as some of the leading municipalities in that region. There's a group called the Pacific Coast Collaborative that brings all the policymakers together on that front. And so there's talks about how to support regional demand and supply for low carbon materials. Not on the policy side, but more on the green building rating systems. In Canada, we have the Canadian Green Building Council, CGBC. They have a zero carbon building standard that already currently has some embodied carbon requirements, and they're working on updates in the next version. Also, LEED version 5 is in the works right now, and I think there's going to be some more significant focus on embodied carbon in that as well. So tying back to the city of Vancouver, where did this begin? Well, as of 2017, actually, we've, as part of the city of Vancouver's rezoning requirement, most of the rezoning projects needed to do a whole building life cycle assessment, more just from a reporting perspective. And that was really important to building up industry capacity initially. And rezoning applies to maybe about half of the new construction in the city. So not all the new construction, but still a good chunk of it. And so that really helped to build up the industry capacity to address embodied carbon and to learn about it, to get used to quantifying this on projects. And then we had the city declared a climate emergency and created a climate emergency action plan. I forget exactly what year it was, maybe 2020 or maybe slightly before then. And within that climate emergency action plan, they defined 6 big moves. And so these were like kind of the big areas where we could drive down emissions in the most significant way in the city. And what was notable was that big move number 5 was focused on embodied carbon. And at the time, that was a very kind of rare thing to see in some of these climate emergency action plans or for municipalities to address it, at least in North America. And so what they set was that by 2030, they're targeting a 40% reduction in embodied carbon in new buildings, relative to the 2018 baseline. So that's basically where all this policy is kind of moving towards, is that by 2030, we're looking to achieve a 40% reduction. So what does the roadmap look like right now? As I mentioned earlier, back in 2017, we had the rezoning requirement. As of October of last year, so in October 2023, we became the first jurisdiction in North America to put it into the building code, because the City of Vancouver has our own building code, the Vancouver Building Bylaw. This was the first time that this was kind of implemented, meaning that it applies to all projects that are, for example, applying for building permit, that are what we call Part 3 buildings. So they're basically buildings that are bigger than, let's say, 6,000 square feet, and excludes 1 to 3 story residential. But anything kind of bigger than that, it applies to those projects in the city. So as of last year, October, there was the requirement for reporting, and that the results could not be, or the embodied carbon on a whole building basis could not be greater than 2x the baseline. So it's got to be less than or equal to 2x the baseline. I'll get more into the specifics of what that means. And then the idea is that in 2025, January 2025, that's when the reduction requirements really start to set in. So between 10 to 20% reduction, depending on the building type. It's unclear what the interim steps will be between then and 2030, but as you can imagine, it likely will ramp up at some point. And then in 2030, the target is 40% reduction. To get into more of the specifics, so as I mentioned, as of October last year, there's a reporting requirement equal to or less than, and it also needs to be equal to or less than 2x the baseline. Crucially, we introduced the City of Vancouver's Embodied Carbon Guidelines, which is something that I'll obviously speak more about in this presentation. And that gives guidance to the practitioners around what assumptions to make, how you quantify a baseline, or what's included in your whole building LCA, et cetera. So the purpose of this is really to kind of work through the kinks and also like build up industry capacity and familiarity with how to work with these guidelines. And then in January of 2025, that's when the reduction requirements set into place. And so these January 2025 reduction requirements are approved in principle by the City Council. However, the actual formal targets will go back to the City Council this year for formal final approval before the implementation of the 2025 code. So it can still potentially be subject to change in certain ways, but currently, the as it stands, the idea is that projects that are up to 6 stories and can be built with wood frame or wood need to achieve a 20% reduction. Now, that can be measured against, for example, a concrete baseline. So oftentimes these low-rise wood frame buildings, which is very common here, are oftentimes built with low-rise wood frame, but we're comparing against a concrete baseline. So it's kind of a higher percent reduction target. For all other buildings that are non-residential or greater than 6 stories, those buildings need to achieve a 10% reduction on a whole building basis for embodied carbon. Additionally, they will also need to meet 1 responsible materials criteria. And so there's a few different categories of what that means: sustainable and ethical materials. There's a category for healthy and transparent materials, another category on circular materials. So there's certain kind of optional requirements, and you need to meet one of those criterias. Alternatively, if you don't meet that 1 responsible material criteria, you could also opt to double whatever the percentage reduction is on an embodied carbon perspective. So let's say you don't meet this one, then this for all other buildings it'd be 20%, and for the low-rise wood frame, they would be up to 40% reduction target. So you could optionally do that too. So let's get more into the specifics of the targets themselves. Previously I was mainly talking about percent reductions, but this also actually applies not just to, there's actually 2 compliance pathways. One is a baseline approach where you measure a percent reduction relative to kind of a hypothetical version of your building based on typical design practices. So that's the baseline approach, which is somewhat akin to how LEED currently does it. So when you're doing for the LEED MRC1 credit relating to life cycle impact reduction, for those projects, it's defined as a percent reduction, and you can define a baseline that way. Alternatively, we've also included absolute targets as well. So you can follow either the absolute limit. So if you're below an absolute limit, which is a kilogram of CO2 equivalent per meter squared of floor area, if you fall below those thresholds and you don't need to define a baseline, you can just kind of comply that way. So this is kind of and I think this is probably an ideal approach for how to implement policy, because it's really hard to set one absolute number that pertains to all building that's relevant for all projects and make that work. You know, the reality is that there's a lot of nuances and differences between different types of buildings and whatnot. And so it can help to also have these percent reduction targets. So for example, this is some data, preliminary data that was collected from the rezoning studies. And I would caveat that all the numbers that you see on here, these can obviously change. These are mostly done kind of in early schematic design phase. So they're not necessarily the most accurate whole building LCAs, because at that point, there's still a lot of like assumptions, and obviously the final design has not been nailed down, but this is some data that we've collected, or that the city has collected for different types of buildings, and you can see the range in emission intensity, so embodied carbon intensities. But hypothetically, I just want to use this to illustrate the point. Right now, we set the benchmark from an absolute perspective, which is the red lines, it's set at 400 kilograms of CO2 per meter squared. This may potentially change for the 2025 requirement. This may adjust ahead of that. But let's say the benchmark is 400. So then if you go 10% below that, that means it's 360. Or if you go 20% below that, that's 320 kilograms of CO2 per meter squared. So depending on the building type, these would be the absolute thresholds that you would have to meet. So if you're below these thresholds, then you don't have to quantify a baseline or show a percent reduction. However, if you're above it, you could still demonstrate compliance by modeling a baseline and then showing a percent reduction relative to that. So naturally, a lot of questions come into play as to like how do you define a baseline and what's included in your study, what buildings elements are included, et cetera. And so this is where the City of Vancouver's embodied carbon guidelines come into play. And the aim of this guideline is to really address a lot of the potential questions that might come up from a life cycle assessment practitioner as they're doing these types of LCAs. Historically, there has not been a lot of great guidance, even for lead projects, like how do you define a baseline? There's a lot of room for interpretation. And so the idea was that we were trying to address a lot of this and try to give more guidance around how to do this, especially if we're trying to put this into the building code. It's a much higher bar, and I think we need to bring more rigor to this than if it's just kind of a voluntary requirement. So as I mentioned before, there's absolute pathway, there's a baseline pathway. If you go down that baseline pathway of measuring a percent reduction, these guidelines give guidance around that, and some of this guidance will help avoid some of the so-called gaming of the baseline or potential for gaming for the baseline. And then the other thing is, that might include, for example, giving baseline definitions or starting point assumptions that you can use for assemblies or at the material level, even down to like what EPDs you should point to when it comes to baseline definition for different materials. And also giving more details around how do you account for embodied carbon reductions for various different design measures, like what happens when you incorporate reuse or reduce parking, or you reduce the amount of material quantities in your project, or you specify or procure lower carbon materials. How do you quantify that stuff? There's also guidelines around what should be included in our whole building LCA modeling. What building elements should be focused on. And in our scope, it's mainly structure and envelope is the structure and enclosure. That's the main scope that's required. All the additional other scopes are optional. So for example, interior partitions or interior finishes or mechanical, electrical, plumbing or site landscaping, all of those are optional scopes at this point. We also talk about life cycle stages. So we're looking from module A to module C. I'll speak more about that later. And then things like special topics like how do you deal with module D or biogenic carbon or concrete carbonation. Basically, those things are reported separately, but they're not rolled up into the main results. And then crucially, there's multiple different software tools out there right now that practitioners will use to do whole building life cycle assessments. So we try to account for some of these tool specific nuances where needed to give practical guidance around how do you actually comply. So starting off with like the baseline definition, we have this perspective of functional equivalence. So we want to make sure that the baseline definition is functionally equivalent. So when you're defining a hypothetical version of your building, we need to make sure that it's as comparable as possible. And so that means it needs to be able to serve the same type of function. And so we specifically call out three different types of functional equivalence. One is from a thermal perspective. So let's say you're comparing your baseline versus your proposed design. From a thermal perspective, you want to make sure that they have a functionally equivalent thermal performance. You could approximate this, for example, with clear wall R value on the wall and roofs, for example. You could also bring it down to a more detailed level if you're doing thermal bridging calculations, although that's not required. You can kind of simplify and use this approximation of clear wall R values. From a structural perspective, the baseline needs to be functionally equivalent from a structural perspective. It doesn't mean that they need to be the same structural system. So for example, you may be designing a mass timber building, but you can compare it against a concrete frame building. And obviously there's going to be differences between those two different structural systems, but it should, and they may come with different like column spans or different kind of nuances specific to each of those structural frames. But it should reflect what would be kind of typical practice in your baseline definition. And there is definitely room for professional judgment on this front. However, we do try to provide some clarity on some of these elements where possible to at least kind of guide some of the thinking. But you can account for things if you've made intentional design decisions to make your structure more materially efficient. For example, you change your column spans or you avoid transfer slabs or you design a lighter structure or you have or facade systems, resulting in smaller foundations. Those types of measures you can actually reflect at. So it's not saying that you have to have the same, material quantities in both the structures. From a geometry perspective as well, just generally speaking, we want to make sure that like the building, the geometry, the program is kind of serving the same purpose. And so there's that as well. And broadly, there's kind of two main approaches to defining a baseline. One is you can kind of use an earlier design iteration of your modeling. So for example, in the earlier design phase, you're doing a modeling of your project. You can use that compared to a proposed design, maybe in a later stage of design. That's a possibility. And there may be still slight variations between those models. But I think importantly, you want to address if there's certain elements that were not included in your early design. Let's say, for example, foundation, you need to still account for those things to make sure that they're functionally equivalent. Or you could use your proposed design as a starting point. So I personally prefer this approach. I think this is potentially more accurate and more functionally equivalent, is that you kind of take a copy of your current proposed design at whatever design stage you're at, use that as a starting point for your baseline definition, and then you basically swap out the materials or the assemblies to reflect typical practice or to reflect industry average values that you would use in your baseline definition. And you want to base this approach is likely most to ensure the most functional equivalence between your baseline and proposed scenario, and that it's modeled at a similar level of detail at the given design phase. As I mentioned, like with the guidelines, we try to address some of the tool-specific nuances, which I think is really important because each of these tools have different strengths and weaknesses, and also sometimes different underlying databases that obviously affect the results. Regardless of which tool you use, you have to use the same tool for this analysis. So you can't use a different tool for baseline versus proposed, for example, and compare the values. However, yeah, we've tried to kind of call out we've designed the guidelines with where these tools are currently at. Now, these tools may change as well. They're definitely changing. They're evolving. They're adding new features, adding new updates to the databases. And so we want to have the guidance evolve a little bit as these tools evolve. Yeah, hopefully this gives some additional clarity. I mentioned earlier from a life cycle stage perspective, when we're doing a life cycle assessment, there's formal definitions for each of these life cycle stages. So module A, A1 to A3, this is oftentimes the main data that you see from an environmental product declaration from a manufacturer. You have like raw material supply, transport, and manufacturing. So everything up until it leaves the factory, basically. And then you have A4 and A5, so transportation to the construction site and any emissions from construction and installation. Broadly speaking, this is considered the upfront embodied carbon. And then module B is the use phase, probably the most significant of which is the replacements, so B4. So if there's materials that need to get replaced throughout the lifespan, over a 60-year lifespan of the building, we account for that as well. And then module C is end-of-life emissions associated with that. Module D is reported separately. That's benefits and loads beyond the system boundary, so the impacts of reuse and recycling at the end of the project life. I'm just mentioning this just to give you some high-level overview because I'm going to be touching in on some of the assumptions next. So, in the whole building LCs that we're requiring, it's module A to C. Module D is reported separately. For module A1 to A3, you should use industry average EPDs and generic data within tools as a default assumption, and also for your baseline definition. However, for your proposed design, if you've actually specified it in your project documents, like in your specs or in your drawings, that you are procuring a lower carbon material or from a different manufacturer or whatnot, you can use manufacturer product-specific EPDs in those scenarios to demonstrate further reductions. So let's say you're using some low carbon mixes from your local ready-mix producer, and they are able to generate EPDs, you can actually incorporate those values into your estimates. And then module A4, so everything from module A4 all the way to module C, you can use the default tool values, or you can modify some of these underlying assumptions if the tool allows for, if you do have higher quality project-specific or regionally specific data. And if you modify any of these assumptions, you need to kind of include this in the design report, which is kind of the Excel submission template. I think this is probably one of the more innovative things that we've done. And it's more to address where there's currently a gap in the market. So if a certain software tool that you're using is missing life cycle stages, because we're requiring from module A to C, For example, EC3 as a database, or the TallyCat tool, which is built off of EC3, or any number of other tools built off of EC3, they currently only have A1 to A3 values. And so you can use those tools. And then what we've done is we've created some placeholder values uh, that are assumptions. So they're defined as percentages of the A1 to A3 values to estimate module A4, A5, B, and C. And this is not meant to be like a claim that this is the most accurate percentages to use. This is more of a placeholder option because currently the tools like EC3 do not have those later life cycle stages. But from our understanding, they are working on this and they will be rolling out those later life cycle stages. In which case, like at which point we wouldn't require these types of things. But they're kind of meant as temporary measures to address these gaps in the tools, because we didn't want to exclude EC3 because there's a lot of low carbon procurement options and manufacturer specific data points in that tool as well, which can be really valuable. And then some other modeling assumptions, we're looking at building lifespan of 60 years. You can use software defaults, or you can kind of override some of the software defaults with some of the values that we have in the appendices. Biogenic carbon storage, as well as concrete carbonation naturally occurring, and land use change. Those emissions, if they are quantified at all, they can be quantified, but they should be reported separately and not included in the main calculation. We ask questions like, what's the bill of material source? How did you calculate those material quantities? Is it from a Revit model, like a BIM model, a cost estimate, and or takeoffs from PDF drawings, for example? Yeah, and then like we also define like what elements. We give a really detailed list in the appendices with like tables on what elements specifically should be included, which ones are optional, and which ones are should be excluded. And it's down to building element classification system from OmniClass, and it's down to level 4, which is very, very detailed. And I think it's really helpful to have this level of clarity because sometimes it's not entirely clear what elements should be included or not when you say something like, you should just look at the structure and envelope, for example, because there's a lot of kind of nuanced decisions that we need to address. And so that can give some additional guidance on that. Broadly speaking, the materials required for both the structure and envelope also need to be able to satisfy the thermal, moisture, acoustic, and fire protection related requirements. So I'm not going to get too in depth into all the specific assumptions, but I just want to give you a flavor of what some of the information is in these embodied carbon guidelines. I should mention that the embodied carbon guidelines, even though this pertains specifically to the city of Vancouver, I know many other jurisdictions are currently looking at these guidelines as a source of inspiration. They may potentially even refer to this. I think there's a conversation right now in Canada at the national level to look at how to build upon these guidelines to turn this into more national guidance in Canada. And I know there's certain other jurisdictions in the US as well that are taking a look at these guidelines because they're probably the most detailed, at least from a practical policy implementation perspective. But yeah, I just wanted to kind of mention that just to frame it a bit. And not to say that these guidelines are perfect, but I think it's very much a work in progress right now. But yeah. So some of the other things that you'll find in these guidelines is having some starting point assumptions by building element. So when you're defining a baseline building, what assumptions should you make for your foundations or for your floors or for long span roofs or short span roofs or exterior walls for different types of buildings or windows or interior partitions. So we kind of give you some starting point assumptions. That's not to say that this should be the baseline definition for every single building. Again, there's always professional judgment involved, but just to give the intention of, we're trying to reflect what would be typical practice for this type of building, for this building element, for a typical building that would be built in this region. So this hopefully gives some starting point assumptions, like what type of insulation to assume in the cavity, or what type of continuous insulation should we assume for the exterior walls, et cetera. And sometimes giving some nuances, like, for example, let's see, where did we have this? For roofs, for example, like we'll say, like for conventional roofs, you should use polyiso as your baseline definition. But if it's an inverted roof, you should use XPS because that's more typical practice. So kind of giving some of these nuanced recommendations as well for baseline definition. So that's kind of at the building element level, like looking at assemblies. But What about the individual materials? So for many of the key material categories, we also give some guidance. So for example, concrete, obviously a very important factor. We talk about which industry average data point to refer to. So in Canada, we actually have provincially specific industry average values. So each province has their own industry average EPD for concrete, for each strength of concrete, and there's many different mixes in there, but for each strength, there's a different baseline mix. And so that's going to be the thing that you use as an assumption for your baseline definition. Obviously, in your proposed design, if you show lower carbon options, you can reflect that. But giving details as to air entrainment or not air entrained concrete, or what strengths of concrete to assume, especially in the earlier design stage, not so much in building permit, but let's say you're in the rezoning stage and you don't know the strengths of concrete, it's not specified on the drawings, we can kind of give you some starting point assumptions as well. And then we have some tool specific nuances because some of these data points do not exist in certain tools. And so we kind of address that as well in blue boxes. Insulation, for example, we kind of call out some specific topics like XPS insulation. XPS has big differences between underlying assumptions. If you use HFC blowing agents versus HFO blowing agents, HFC is hydrofluorocarbons, which is basically like refrigerants. And they have very high global warming potential. And basically their results can be, 10 to 25x higher than the new versions of HFO-based XPS insulation. And so we kind of specifically call out what assumptions to use for baseline for stuff like that for both XPS as well as spray foam insulation. And then rebar, some special topics like how do you address post-tension slabs and post-tension tendons where there's oftentimes not data points, or at least within certain tools around post-tension tendons, and how would you kind of quantify that? So there's I mentioned there's assembly level assumptions, there's material specific assumptions, and then we also have a section talking about how do you handle special topics for how you might quantify reductions in embodied carbon. So for example, one potential strategy is that you want to reduce the amount of underground parking. And in doing that, we actually give specific methods for how would you actually quantify that. Let's say there's like certain parking minimums set by the city, but I think the city is actually looking at relaxing some of those requirements or removing them. And so, how can you demonstrate that you've intentionally kind of reduced the amount of parking required for this project? There's different strategies for stuff like that. There's also, we give some clarity around like, how do you account for structural material efficiency savings? So if you design your structure in a way that's more materially efficient, what things can you account for and how much you do that between your baseline and proposed scenario? So we kind of address some of those points. So yeah, that's kind of an overview of the guidelines, which kind of detail a lot of the assumptions that you use. In addition to the guidelines, there's also the City of Vancouver's Embodied Carbon Design Report. So the design report is basically a spreadsheet submission template that collects some of the project specific data. So this is what the spreadsheet template looks like. There's many sheets to it, but basically we're collecting data about the project. So you could think of this as like the project metadata. So what's the project name, the address, the submission date, the number of stories above grade, below grade, gross floor area with and without parkade area, what's the primary building use, what's the design phase, how did you do your takeoffs, what's the primary structural material system, foundation type, software tool, life cycle stages, et cetera. So this is kind of the metadata around both the project and also the whole building LCA modeling that went into that project. So we collect this submission template. And then we also collect the raw granular data as natively exported from the different software tools. So like Athena, Tally, One-Click LCA, EC3, they all can spit out results in more granular fashion. And so we actually request that raw data as well, which includes oftentimes material quantities as well as the GWP or the embodied carbon of different material categories. And so and within that spreadsheet submission template, we actually have a link to a page where I've actually embedded some tutorials of like where I've basically recorded video tutorials for like how specifically to export the results in exactly the format that the city would want basically to receive it from. And the reason why I'm bringing this up is that I think this is actually critical from a policy perspective. There's a lot of discussion around how to harmonize and align methodology. And at the whole building level, I think it's really important that we actually start collecting this raw data as exported from the different tools, as well as standardizing on a kind of a submission template. And with this actually enables really robust benchmarking of the projects, and also it'll allow for some quality assurance checks as well on the results, rather than just basically having practitioners just share the rolled up results, like what's the total embodied carbon of this whole project. If you just get that flat rolled up value, it's really hard to kind of figure out what went into it and how comparable these results are with other types of results. And so by setting up a good foundation for this, I think that's really important. And I would say, like, if there's one take home message that I would say or key takeaway message for all of you as you're thinking about how to potentially implement policy in Denver and in the wider region, or wherever you're based out of, is, oftentimes you need to start with disclosure, right? You start with whole building life cycle assessment disclosure. In the US, there's many policies that are more buy clean type policies that are looking at individual materials and setting, emission thresholds or GWP thresholds for different specific materials like concrete or steel or glass or insulation. But when you look at policies that look at the whole building, meaning all the materials in a building, I think there's a lot of oftentimes you want to start with a disclosure requirement, and that actually builds a lot of industry capacity to do this type of analysis. And as you're doing that, I think it's really helpful to start collecting this raw data. And so setting up the kind of the right foundation for you to collect the right types of data so that even if you don't know what you're going to do with that data yet, and I think there will be solutions that will address this in the future, but basically that will set up the right foundation for you to really implement this policy effectively as you move forward. So with that, I'm actually going to turn it over, or we're going to have Q&A. So any questions that you have, I'll just stop sharing my screen. So I'll just open it up.
Thanks so much, Anthony. I will take a look at the Q&A, see if we have any.
Oh, sorry. I think my speakers just turned off briefly, but did you say something, Dorian?
I'm just going to take a look to see if we have
okay.
one question
Great.
In the Q&A, and then I'll open it up to the floor, and whoever wants to ask a question, just turn off your mic. Turn on your mic. So we have a question. Can you touch on variables for historic/heritage properties or existing buildings that would have difficulty meeting the standard requirements? Also, are there incentives or other flexibilities for life cycle modeling costs for small business/economically disadvantaged communities?
Yeah, great question. So first off, I think for the first part of your question, actually, this policy only pertains to new construction. So it's not looking at existing buildings, and we're not also looking at like retrofits of existing buildings. This is specifically only to new construction projects. So that's what the policy would focus on. So yeah, the existing buildings would not need to meet the standard. Because mostly for existing buildings, like the embodied carbon's already a sunk cost in a way. You've already kind of built the building. There's definitely an argument to be made that, like, if you retrofit versus building new, like obviously from an embodied carbon perspective, it's advantageous to not demolish the whole building and build a new one, right? But yeah, just for the purposes of this policy, it's mainly targeting the new construction. And then you mentioned, are there incentives or other flexibilities for life cycle modeling costs for building? That's a good question. At least with typically the projects that we're addressing in this policy, they're like larger scale projects, and so I think the scale of costs associated with kind of doing the modeling would be a fairly small fraction of like the total budget. But that said, costs I think are something that the city is very keen to look at and address and make sure that like the policy is implemented in a way that also is like equitable and like not disadvantaging different communities. I think when it comes to embodied carbon, there's actually quite a lot of like low-hanging fruits that are actually fairly cost neutral or like not significant in terms of the increases in costs associated with relevant to the reductions that they can achieve. And so, I think the first, 10%, oftentimes you can actually do quite a bit, oftentimes with like little to no cost increases on that front. Yeah.
Great. Oh yeah, and Jennifer clarified, i.e. affordable housing projects. So kind of incentives around.
Yeah, that's a good question. I think like that's also something that's on the city's radar. I can't speak fully on behalf of, so just
Right.
to clarify, I'm not with the city of Vancouver. I'm one of the consultants that basically was advising them. Um, I think that's definitely on their radar, and I'm not sure what, yeah, if they have any specific programs or what they're thinking on that front.
Understood.
Yeah.
Alexis has a question. What discipline is typically performing these LCA calculations and showing compliance? Architects, engineers, contractors, sustainability consultants, etc.
Yeah, great question. I mean, to be honest, it's a mix. I've seen all of the above actually, uh, doing embodied carbon or life cycle assessment calculations. So in Vancouver in particular, I would say like I can see in the local market, many of the big firms, or many of the firms, not just big firms, are actually developing in-house capacity. So like architects, structural engineers, all sorts of and also the sustainability consulting groups. So like the groups that are doing lead or energy modeling, they're starting to kind of build up in-house capacity. Um, and there's a few like us, like a very few that are kind of specializing in doing just LCs. But yeah, I mean, I think it can be done by different disciplines, and sometimes there's needs to be coordination between the different disciplines. Like let's say the structural engineers doing embodied carbon, well, they're oftentimes looking at their structural scope, and then the architect may be potentially looking at the envelope scope. So there's going to be some communication as to how those results match or who takes the modeling from what. So but yeah, I've seen all of them, all of the above. Contractors as well. I think they're starting to look at this as well. Yeah.
Awesome. Um, oh,
Mikhail?
yeah, Michaela has her hand up.
Hopefully my mic works. Is it working?
Yeah.
You can hear me. Cool. Um, nice talk.
Thanks.
I was thinking about, all kind of all the new policies, buy clean or whole building, kind of all the different styles, and I'm always kind of curious about unintended consequences or kind of unfairnesses that creep up through policy. That wasn't really the intention, but sometimes we have to like design the policy or switch the policy over time to avoid those things. Um, and I'm curious, I guess I'm curious what your thoughts are on that. Are there any you foresee being a problem, or like,
Are there
I
any
guess
things
my
that you
head
kind of
always
think
goes to
of,
like
like when you're like, is
biogenic
there
carbon,
examples?
or yeah, or just like, is there anything you foresee that could be a pain point that hopefully will be addressed? You know, we have this period of disclosure, which was great because that you can kind of deal with them during that time. I'm just curious if you have any foresight you kind of see on this.
Um, I would say that like, yeah, I mean, definitely the disclosure period. I think that's like a relatively small ask and like it's like kind of lower stakes in a way, right? During that period. And so hopefully you can kind of iron out a lot of those kinks. And especially here, we've been doing this since 2017, at least in the local market. So like we built like I think the local industry is definitely like probably much further ahead than many other jurisdictions in terms of like their capacity to address these things. That said, I don't know that we can anticipate every single possible thing. However, with the development of the guidelines, I think that there's been multiple rounds of industry feedback that we've invited. So 3 rounds actually in the development of this. And we've had feedback not just from people from City of Vancouver or even in Canada. Like we've had folks like from across like North America, including the US, that have been providing a lot of really good feedback. So that's kind of helped us um, try to anticipate some of the potential issues. That said, I don't know that we've like addressed everything. There's no way that we would have addressed everything. So a lot of this like sometimes comes down to like the implementation of it and actually being really receptive to like the feedback from the industry and trying to figure out what works and where do we need to kind of relax things a bit, or requirements, or create kind of allow for exceptions, for example, for things that maybe we haven't accounted for. I think in the implementation of this, there's some, I forget the specific language, but it's something like meeting this requirement or as approved by chief building official. So in a way, there's kind of like an option, like, if the chief building official approves of it, like, and maybe there's some circumstances that we didn't like, identify that's very unique about the specific project, and there's something that we need to address. Like, there's kind of ways of addressing that. So I think we have some of those types of mechanisms built in as well. But ideally, like we don't want to go down that path like very frequently for every project, right? So like the more that we can anticipate in advance and get it right in the actual policy, the better. But I don't know that we can always be perfect with these things. So the we just got to test it and see.
Yeah, cool.
Victoria had a question. How is the review process going to work? Is the database/disclosed LCA going to be available to the public?
I think that's still being ironed out right now, but I think there's potential for doing really robust quality assurance checks in a way that, well, actually, I don't think I can speak too much about this right now. I think there's definitely ideas in the work on this front, but I think how that gets implemented will be really critical with how this policy actually gets scaled. I think how you do quality assurance checks and if you can automate that process would make a huge difference in terms of how policy actually gets implemented. So I think that's something that the city is actively thinking about right now, but the details are still being ironed out on that.
Got it. Scott, you have your hand up.
Yeah. Thanks for coming, Anthony. I really appreciate a lot of the work that you've done in, exposing blind spots in LCAs across the board, but especially with wood. And want to thank you for coming here to the Rocky Mountain chapter, where we're definitely more challenged on the issue. So I'm wondering, you got issues with mass timber over there in terms of sustainable harvest. How is Vancouver dealing with the different sustainable harvest certifications, more specifically FSC versus the timber industry SFI? I've seen your maps showing the different volumes of certified area in BC, which is more than 100 to 1, I think, SFI compared to FSC. But just, in terms of FSC is really focused on trying to get the amount of carbon leaving the forest equal to the amount being sequestered by the forest. Is Vancouver doing anything in terms of the sustainable harvest certifications?
Yeah, that's a good question.
Going along with LEED, they're all the same. That ought to change.
Sorry, I cut you. So as I mentioned on the modeling side for life cycle assessments, when it comes to biogenic carbon storage, at least currently right now, we've said this can be reported separately, but it should be not included as in not rolled up in with the main results, like when you're calculating a percent reduction or when you're calculating the absolute embodied carbon threshold. Currently, the guidance is to not include that. Now, that said, I think the city is interested in thinking about how to address biogenic carbon in a robust way. I think there's also definitely challenges around that. So that's something that they are thinking through currently. And there may be updates to the guidelines. Actually, I think they are working on updates to the guidelines as well in advance of the 2025 update. So that's one of the questions I think that the city is going to be exploring. But I think more specifically to your question about certifications, as I mentioned earlier, there's the kind of the whole building LCA and the percent reductions that you achieve there. But then there's also this responsible material criteria responsible material criteria. And I think the specifics of that language is actually also going to be addressed and potentially updated for this 2025 update, which will likely come, I don't know, maybe in the Q2 or Q3 of this year, I would assume. Those are some things currently right now there is some language in there, but I think they know that they need to kind of look more in depth into that as to how they're going to address. And I think there may be some stuff that looks at wood. I can't recall. It's been a while since I looked at it, but yeah, all that to say, that is something that we're planning to look at. But right now it's not influencing the numbers directly on the whole building LCA.
And when you're involved, Anthony, I think I have some faith that Vancouver will not go down the path of LEED, saying that all North American wood is absolutely sustainable due to tracking whether or not it's illegal. I think you're a little bit better than that.
Well, I don't know if I can't comment on where LEED's going on that front. So
I think with the National Sierra Club, though.
Sorry, I didn't catch that. What was it?
I think I might be commenting on that with the National Sierra Club.
Okay,
Got it.
Yeah,
Thank you.
thanks. Yeah.
Alrighty. Victoria, you have your hand up?
Yes, thank you, Anthony. Great presentation. I just have a question. Well, I have a couple of questions, but one of them is in regards to the B1 through B5 life cycle stages for when you're using the EC3 tool or any other tool that you will have A1 through A3, even if you just use the EPD. Do you have additional guidelines for specific to material types based since given the fact that different materials will have different replacements?
Yeah, and so I mean, this is some we actually do. We did put that in the appendices, but we're not saying that that's a requirement. I think you can use the tool defaults right now, but I also recognize between the different tools, they actually have different underlying assumptions, like on the default service lifespans that they say. So it's one of the many areas that I think could use some alignment, across the tools, like at least the default assumptions. Like you can override these assumptions if you have better data or more project or regionally specific data. But I think aligning the default assumptions would make a big difference. And currently we're not there yet with the different tools. We did actually include in the appendices, which is kind of pulling from various different sources of data that we've seen for material replacement lifespans as more of a starting point. We're saying like you could use these, you could also use the tool defaults, you could use these if you'd like, or if you have better data, you could use that as well. So we're not giving like firm guidance on like you must do this type of thing, but I think it would be beneficial to actually align those default assumptions between the tools, because that could actually lead to some of the bigger variations, especially when you're not as much on the structure, but when you're looking at enclosure, and especially later on if we expand the scope to potentially look at like interiors or MEP, like those things will actually become more consequential.
Thank you. Thank you. And the other question that I have, more comment or not comment, what is your feedback or like your recommendations for this hub? Like many of the members are always looking for trying to help the policy in Colorado to change and to address these things and maybe be even more progressive, which I believe Colorado is kind of a progressive state right now. But so what hurdles did you see along the process? What you said that you started in 2017, so and we are 2024. It's like a really long process, it seems. So what are your recommendations or tips? Thank you.
First off, I'd say that back in 2017, the industry was in a very, very different place compared to where it is right now. So I would first off say, like, even though you might think, oh, like, yeah, obviously there's been many years that at least in the local market, like the city of Vancouver practitioners here have been kind of addressing it. That's not to say that like it's going to take as long for all the other jurisdictions. Right now, like the tools are in a totally different place. The amount of education, even just the amount of like conversation around embodied carbon is like drastically different than where it was back in 2017 when many of these resources didn't exist, right? So I guess my recommendation is there's definitely a place for like the buy clean policies. So I don't think like it's like an either or, like which policies are better. But I think it is worth also looking at kind of the project level, meaning like whole building life cycle assessment, or if you're looking at infrastructure projects, looking at like the whole infrastructure, all the materials in there, to actually start at least including a disclosure requirement, because that's ultimately, I think, how you're going to be able to address other types of emissions that way, right? You can address like design measures. So even irrespective of what material you or like what concrete you're procuring, you can address, like, for example, the material efficiency strategies. You can address other materials that are currently not covered in those scopes. It's not going to be feasible to do buy clean for every single material in a building, right? And even you can see sometimes like some of the buy clean policies, they might look at insulation, but they only look at like, one type of insulation. Well, then what about all the other forms of insulation? And how do you actually address this? And especially if you think about when we move beyond just structure, and we look at some of these other materials, at some point you actually really, I think, to future-proof this policy, if you think like MEP emissions are important, or interiors are important, or landscape emissions are important, at some point you're going to need to like also look at the project level emissions. And so I think trying to, wherever it's possible, to incorporate these whole building or project level requirements. And obviously start off with disclosure requirements. I don't think you need as many years as like the city of Vancouver did, but like that, that will do wonders for building up the industry capacity locally and also get everyone familiar with the process. And then once you've kind of ironed out some of those kinks, and oftentimes there's going to be a lot of templates to kind of follow from, right? Like I think Calagreen right now has like an either or approach, right? Like you have 3 compliance pathways. One is, kind of a buy clean approach. One is like a whole building LCA with 10% reduction. And then the third one is a reuse pathway. Maybe Colorado could follow something like that, for example, right? Yeah, I would say start off with something like that. Start off with disclosure, build in that requirement. And yeah, I think from there you can kind of build on the policy. That would be my main recommendation. And and also like maybe you can't address all projects, but then okay, then address like municipal projects or state level projects. Oftentimes, like those are things that like they have potentially more control over, and demonstrating leadership at the government level, and before ahead of like if they're thinking about putting this eventually into kind of a broader rollout, that could be also one strategy.
Thank you for that input.
Mm-hmm.
Well, we have just about a minute left. If minute or two. Anybody else have any questions? Okay. Well, this recording will be available shortly if you have any colleagues that are interested in this topic and couldn't make it today. So stay tuned for that. And thank you again for coming.
Thanks, everyone. All right, cheers.
Thank you. Bye.